All right, so moving on to completing the square for hyperbolas now. Hopefully, after doing circles and ellipses, we got the basic idea of what we should be doing. So a lot's not going to change, and that's why, again, I have the same steps listed up here. There's going to be a couple things that are going to happen as we go through these that we're going to make adjustments. But number one, we're still going to get our x stuff together and our y stuff together, constant on the opposite side. But what we need to deal with in terms of hyperbolas is that A and C have opposite signs. And so what I always want to do when I have an hyperbola is I want to put the positive piece first. So positive A or a positive C goes first. So in this case, because my x squared part is positive, I'm going to put that first. Then my y junk, and then throw that 20 to the other side. Still need to have my quadratic coefficients be equal to 1. Okay. In this case, my x piece is, okay, but my y piece isn't. Okay, so it's the same idea. I'm going to factor out A if I'm dealing with the x's, C if I'm dealing with the y's. Okay. So what I'm going to factor out here, I want to take the sign with it. I want to make it a positive one again. So what I have to do is divide by -4. And so that's where we have to be very careful, because we need to remember that when we factor out a -4, we have to take the negative out of both parts. And that's a common error that people will run into, is they'll forget about dividing by that negative. Okay, so that -16, when we take out the -4, actually becomes a +4. Okay. Just like we've been doing, add half our linear coefficient to both sides. So here again, I'm going to take half of 4, which is 2, square it, and get 4, and I'm going to add that. But again, remember the idea to distribute. But this time when we distribute, I got to take that negative with again. So I'm actually not adding 16. I'm subtracting 16 from both sides. Okay. Now, if you notice, I haven't done anything with that x squared piece. And remember, we've run into this. Again, x squared. I already have a perfect binomial square there. I can take x minus 0, x plus 0, whichever one you prefer, and square that. It's still the same thing. Okay. So now let's go in and rewrite as perfect binomial squares, which I actually just did with the x part. Okay. The -4, my y is going to become half of that linear again, so half of +4 becomes +2. Combine over here, and we get 4. And then, just like with the ellipses, we want to go in and make that constant value equal -1. So I'm going to go in and divide, or +1, I'm sorry. So I'm going to go in and divide everything by 4. Okay. And same ideas with the ellipses. If you don't get something that's a factor of your denominator out in front of your parentheses here, you've probably made some type of an error. Now, your 4's multiply out, but I always want to put something down in that denominator, because I need to have a value to take the square root of to know which or how many steps I'm going to take in that direction. And so there is your standard form for that hyperbola we started with in general form. Okay. So now, just like the other one, same idea. What I want you to do is go in step by step, okay, pausing the video as we go, and see if you can get to that final solution of your standard form. So pause it and do step. All right, so again, because the x squared is positive, I went with that first. Now, if the y squared stuff was positive, that's what we would put first. Okay, whichever one, A or C, is positive, that's what's going to go first. Okay, so go ahead now and pause and do step number 2. All right, so with the x stuff, again, I factor the A value out, so I factored out my 9. The y stuff, I factor out the C value, which is at -16. And so again, remember, if I'm dividing by -16, negatives go to positive. Okay. Make sure you divide that negative out of that linear piece as well. All right, pause and do step number 3. Okay, so again, half of negative 4 is negative 2 squared is positive 4. But again, remember, 9 times 4, I'm actually adding 36 there. Okay, same thing with your y's. Half of 6 is 3 squared is 9. But what I'm actually doing is negative 16 times 9, or negative 144 to both sides. Okay, so now pause, do step number 4. All right, so again, when we rewrite it into our perfect binomials, the half the negative 4, half the 6. Okay. Jump into step number 5, get your constant to be 1. All right, so again, to get your constant to be 1, we're going to divide it by itself. So I'm taking negative 144 divided by negative 144. So one thing that happens here now, when I do the 9 divided by the negative 144, I get a negative. Again, 9's a factor of 144, left me with 16. The negative and negative went to positive. Standard form for a hyperbola, again, is the positive piece first. So what I need to do with this one then, before I'm all done, is just flop the x part and the y part around. So I have my positive piece and then my negative piece. All right, let's look at parabolas, because they're going to be a little different as well. But I'm going to, again, try and follow these same steps that I've been doing throughout. So number 1, when we said put our x stuff together, our y stuff together, constant on the opposite side, I'm going to change that a little bit. Okay? What I'm going to do is my squared stuff equal to the rest. And what I mean by squared stuff is which one of my variables is squared. Is my x squared or is my y squared? So in this case, my y is squared, so I'm going to put the y junk all together. But everything else, okay, my non-squared variable, so here the x, and my constant go to the other side. All right. Now, quadratic coefficient needs to be 1, okay, which I have. Okay, so I don't need to factor anything out here. If there were a number involved there, I would factor it out just like I've been doing. Okay, I don't need to factor out the 4 of the x because that's not quadratic, that's linear. Okay. Step number 3, add half my linear. Okay, I only have to do this to one of my variables. Okay, because I don't have x squared, I can't complete the square. I can't just introduce an x in there to make it x squared. All I have to do here to complete my square is deal with the y's. So I'm going to take half of my 6 and get 3, square it and get 9, and add that to both sides. So I'm going to get then my perfect square is just going to be on the one side. Y plus 3 all squared equals 4x minus 16. Okay. Now, the piece that I will add in here for step number 5 is factor. So the linear coefficient equals 1. So now I'm going to go over here with my x piece. I'm going to factor out that 4. And now I have my standard form for my parabola. Okay. So just a little change there, not a big one. Okay, because the fact with the parabola again, remember one of my 2 quadratic coefficients has to be 0. So I only have one part to complete the square with. All right, so here's yours. Okay. Go ahead and do step number 1. Okay. Well, I didn't have to do anything, did you? Okay, my x is a piece that's squared. Okay. Okay. My y stuff and my constant are what got put on the opposite side. Okay. Step number 2 is actually done as well. Okay, I already have my quadratic coefficient as 1. Okay, so go ahead now, and really what I need you to do next is step number 3. All right, so step number 3, half my linear, so half of the 4 is 2, squared is 4, so I added that to both sides. Do step number 4. So again, x with half my linear, so x with half of 4, okay, which is positive 2. And then I combine my constants over there. Okay. And step number 5, to get your linear coefficient to be 1, it already is. Now, one thing I might do with that situation is still put a number out in front. Okay, even though I'm not factoring anything out, I might put that 1 out there just so I recognize, hey, my value for 4p in this example is equal to 1. All right, so I hope these things help you out with these completing the square problems.